What the first thing that we are going to talk about from the beginning to the end of page is the word confirmation. Now, usually people start with defining a thing, define it and then proceed, which I am not going to do. Probably, I may not be even defining it till the end of the main course. But the idea is that if you understand what it is, it's more than enough rather than defining what it is. So, with the aim is we have to understand the confirmation, for which we now first will have to concentrate on the basics of confirmation. This learning of confirmation, I would say, is similar to your learning a language. I am sure you would have known that there are many ways of learning a language. There are two schools of thought. Just if you take any language and then you start with a picture and then say, what is this, what is this, what is that? Let us say this is cat, this is something, and then you say the cat is a word, it has got letters, it has got alphabets, it has got consonants, and so on. The other way is the right way, start from an alphabet, A, B, C, D, A, E, E, whatever you can think of in whichever language, and then build up from the letters to words, words to phrases, phrases to sentences, sentences to essay. Now, I will be adopting the second method, namely, we will even not know when we are reaching the stage of confirmation per se, but we will start with something which is very basic to the thing, which I will call it as actually is a basics, or you can even call it as foundation to the confirmation. So let me ask the question, the confirmation by itself is something which is going to be applied to something. So what is that to which the confirmation is going to be applied? The confirmation is going to be applied to molecules. So the next thing which I am going to ask is molecules. If I have to know about it, I go down the line and then I know that the molecules, if I have to know about atoms. Well, as I mentioned in the last class, or the last lecture, that many of the things that I am going to say in the first one or two things are something which you know very well, which you definitely would have seen at some part of your career earlier. But in order for the completeness of the course, as well as in order that you know these are the things from which you have to build it up, I am sort of repeating it. But at the same time, you will notice that the approach which I am making is not going to be the approach with which the conventional subjects are making. For example, if you take the atoms, the physics people have learned the atoms in a different way, the chemistry oriented people have learned the atom in a different way. And how are we going to start it? If we are going to start in this physics people way or the chemistry way, or I don't know, I am not a biology student, so I have no way of knowing how the biology oriented people learn atoms in their courses. But let me put it this way, we will start it in terms of saying that according to my definition, we will say, we will just put a point here and we will call it an atom. So, the next stage of my type of lecture will be, if you are going to say some of the atoms, I will ask the question, if we are going to talk about the atom, how am I going to represent the atom? So the next thing will be going along with that is, how exactly we are going to represent it. So when I represent the atom by a point, so it is called a point representation of an atom. So please do not get confused with the way you have learned the atom electrons, protons, etc., charge density, charges distribution, different ways of knowing it. But we have in our course, we don't need to bother about it. We just, it's enough we know that if you are going to say an atom, it's going to be represented by a point. And we just branch off from here to see something. Incidentally, this branching off from the mainstream to the other stream is going to be very common in our course. And those of you who are familiar with the programming concepts, they call it a subroutine concept. You branch out from the main program, go to the subroutine, come back. Or if you are in a window concept, you open a window and click on something. After finishing it, click the back button and come back to the original one. All of them are the same. So we will say that if I am taking a point, and if you're asking it in terms of a more sophisticated way, a point is called a figure of zero dimension. If you don't know, if you find it a little bit confusing, don't bother. But we start with something like 0, which is the basic for all mathematics. Binary, anything you want as 0. But you can't define 0. Vacuum cannot be defined. So you start with something which is a point, and if you want to say something more, nothing, that's all. So we are not going to say anything more about the atom per se here. Though there are very many things that can be said about the atom in different contexts. As far as we are concerned, we will say that whenever we are talking about an atom, it is a point. Therefore, in the series of lectures, the two terminologies, atoms or points, whenever I am mentioning it, they become synonymous. So they are used alternately. It doesn't, when I say atom and I say point, why do I specifically say this? Because I just now mentioned some time back that you have to be precise in everything. So definitely atom is a word, point is a word. So when you say atom, do you mean point? When you say point, you mean atom? When I say synonym, then that becomes, you don't need to bother about that aspect of precision when I am mentioning about the atom or the point. So throughout our course, we will be talking about point atoms. Now, as you know well, that 0 is powerless by itself, nothing. But the moment the 0 is added to something else, it becomes very much significant, because you know that this is and this are very different. The difference these two have made is zeros. So 0 is powerful the moment when it goes into something else. So like that, we will say one point, we just put it in atom, it's not of much use here, but the power is going to be introduced here by saying that I have another atom which I am representing by another point. Here again, when I say this is an atom, I am not precise. So I will be, rather I must be more precise to say that there must be some way of denoting these atoms. So the precision level which I am expanding now is, I say, this is an atom which I call as A, and this is an atom which I call as B. Then I am going into a little bit more of precision. So right away, if I say, instead of saying this is an atom, this is an atom, if I say this is an atom, let us call it A, this is an atom, let us call it B, I am becoming a little bit more precise. Or these are two atoms which can be denoted by A and B. So throughout again my talk and my lectures, you will find that this aspect I am emphasizing every time, namely that you have to be very clear, you have to be very specific in what you say. As you go by, you don't need to take any special effort to do that. If you have followed the class and followed it regularly, it will automatically come to you. Again, go back as it's taking language. if mother tongue, when you are talking, do you take a special step to, or a special effort to say something, it comes automatically. So I want this after the course, the confirmation, to be your mother tongue, to that level. So we will say, so we said that there are two atoms which are denoted by A and B. We proceed to, when there are two atoms, is there something that I can talk about? Yes. Now I can talk about the distance between A and B. So the next step I am going there is A and B are there. I can talk of what is called the distance between A and B. So what do I call this quantity? What do we call this term distance? I call this as quantity. So now we have started with the confirmation and the things which are now representing ourselves. As I said, first it is a representation. Then the second is symbolic notation or denoting. Third, I am going to talk of some quantity. So when I say the distance between A and B, I am going to the next level of precision. So this distance is a quantity between two of these. So the next thing is, when we go to the, when we say the distance between A and B, we come back and then say, how do we denote the distance? We say distance AB or distance between A and B. I would prefer you to use the terminology distance between A and B rather than distance AB, though in a common sense everybody understands distance AB as distance between A and B. For example, if you want to call the distance between Bangalore and Chennai, you say distance between Bangalore and Chennai is this. You don't say distance Bangalore-Chennai is this. So the between is the commonly used, but here somehow or other people have found that between is useless. So they say distance AB, it's okay. But so this distance is a quantity. So we come to the next idea of a quantity. Everywhere you will see, first lecture you will find that certain things are so elementary, so well known, that why is it being repeated again? The reason is, as we go further and further, at every stage these are the things which you have to keep in the back of your mind for representing and for expressing yourself. Okay. So now when you have the distance between A and B, as I said, how do I represent the distance? The representing the distance is normally in a diagram like that. You call it, you do it as a sort of a, let us say, dotted line. When you say this as a dotted line, then you are representing it is a distance. So long as you don't do that, you have some 2 points. That's all. Now, when you have these points A and B and you call them as atoms, any 2 atoms can be there, you can have distance. But under certain circumstances, these 2 atoms are, let us say, connected, you can call it, or have, say, a force acting between them. When there is a force acting between them, then it becomes not 2 independently existing things, but you have one system. Now, that one is very well known, and that is the one which is known as bond. So when do you call these two atoms as bonded is when there is some force that exists between them. I will not be going into the details of this force which exists between them. That is the value of a different set of lectures in a different field. But for us, we know that if there is a force between them, then we say that there is a bond between A and B. In such an instance, why do I bring that idea of a bond? If you have an atom, let us say A, and you have an atom B, and if it is bonded, the conventional way of representing it is not by this, but by a. So here again, if you draw 2 points and draw a line, automatically you are implying it is a bond, it is a convention. Now, for better understanding of various concepts that we will be seeing in the next few classes, it is not only necessary for me to repeat the things a few times. Some people may not like it, but please put up with that. It's not also enough if I just write it on the board, but a third important thing which nowadays is coming up also very fast is called visualization. I don't need to go to the Newcastle. I don't need to carry this terminology to the 21st century scientists. The best thing nowadays, or the thing which is very much used for the visualization, is computer graphics. There are lots and lots and lots of things are going on, picture animation, and so many things with the computer that people sometimes forget there's a real world. In order not to do that ourselves, we will always be using what is called the physical visualization. I would like you to slightly think you are in a previous decade when these things were up, previous 2 or 3 decades ago when these things were not there, how it was. But the advantage of it is, once you see as a visualization, physical visualization, it goes into your mind in a much, much better way. That I can assure you. So, we will be using some sort of a physical models to represent that. For example, one such thing will be to take a ball of this nature and call it as a representative of an atom. It is a sphere. So it has got space, and so you can see it. If I want to draw a sphere on the board, I cannot do that unless I am a good artist. But the other way is to put it as a small circle. So it depends upon which dimension you are talking of. If you are talking of space, then the sphere is a better model. If you are talking of a plane, circle is enough. Less than that you cannot go, point only. So one type of model which you will come across in computer graphics and other things are what are known as ball and stick models. That is, an atom is represented by a sphere. So we will try to go back and then see whatever I have said in terms of the physical visualization of the physical model. Okay, now I have an atom, representation of an atom, I will call it as an atom. So this is sphere. But which exactly is the one in this which is the atom, the center of the sphere actually represents the atom. Now, I am having the atom here, I can keep it here, throw it up, catch it, whatever I want I can do, it will be moving around. I have another atom here, keep one in left hand, one in right hand. I want to move it so many places. I can move it as much as my hand can take it, everywhere it moving. The moment I am thinking of a force that acts between them, the moment I am thinking of a bond that exists between them, then I can't do this job very freely. I am now forced to do it in a particular way, for which you have a small rod which is connected to this, and once I connect these two, then still I can have a movement, but this movement is not as it was earlier. But if I take this atom here, automatically this will follow. If I take this somewhere, it will follow. But in all the cases, you would see that the bond is still present here. But and so the idea is that the rod which is connecting here, physically it is a rod, but for our concept it is a bond. So whenever you have a bond, you have this rod, this type of models it comes as a. Now, so in the visualization part of it, this ball is this one, the stick is this one. So this type of model, you will find it in that case. Now there is another type of representation in which you do not have any specific representation for an atom, but you have a representation for a bond, not in terms of, but in terms of just line. You just draw a line and then call it a bond. So if we say that in a representation, what do we mean? We mean that when we draw a line and call this a bond, we assume implicitly that the ends of the lines are the ones occupied by the atoms, point atoms. And if you have very many bonds connected and so on, you get what is called a rod model, if it is called, sometimes it is called a Kendrew model, various terminologies are there. So this is another type of representation where you find on the screen only various lines going this and that and that, and so on. So much so, we are now said quantity, and we said there is a connection between A and B by a force, then we called it as a bond. And when we are talking of a bond, when we say the distance between two atoms which are connected as a bond, then we don't normally call it as a bond distance. Normally we don't call it, but we call it by a name called bond length. So, this quantity bond length falls under the category of another terminology, which again we want you to learn, is sort of what is called parameter. I am sure all of you have encountered all these things in your earlier education or the career, but now I am giving you from a different angle, that's all. This angle is needed for us to proceed to build up our course, because this basis is important for understanding the later things in a correct way without getting any doubt. So we call this bond length as a parameter. So not bond length, I mean there are more parameters, we will come to that. But so when I am talking of a parameter, I am talking of a quantity, and that quantity is not any quantity but a specific quantity. Now, so we go back to a slightly different thing here. Okay, we have talked of a bond length. We said the distance. Next question which normally rises is, what is the unit by which the distance can be expressed? Obviously, the distance cannot be expressed in kilograms. So they have defined these various things in the elementary units and dimensions. So we have to express it in terms of some units, and the unit of a distance is context dependent, as you know. though they are related. A light year is related to an angstrom. If any of you are curious or brain thesis, you can find out what is the relation between an angstrom and a light year. But both of them are distances. So it is not just the distance, but for us in the conformation field, if you are talking of it, what is the unit by which the parameter, the quantity distance, again watch carefully, I am not saying the parameter distance, I am saying the quantity distance or the parameter bond length is represented. Now, at this place I again have to branch off and then tell you something which is generally applicable to the end of it. I will not be exactly covering everything in my part of it. I will be covering the basics and the ideas and how they have developed and what are the things which you should know. But there are many more things other than what I am teaching. Like one of the things which I will not be covering here are what are called the details. These details are available plenty everywhere, starting from the book up to the web. Wherever you want, you can get the details. So that part of it is something which you have to supplement for yourself. Or in other words, you have to do some work on your own, individualistic, to supplement the information content that I am passing on to you, in order that you will get clarity of thought after getting the details also. So to that extent, some of the things, if I have not covered in my course, it is simply mostly because that those things you are all mature people who have come a long way up, and so you are capable of covering it by yourself. So there is no necessity for me to cover it. So please you supplement it. So we come to the main thing. That is what I said, branching off to the, then coming back to the main thing. Hopefully I will come off, not go off from there and end up. So when you come to the unit, so what are the units by which a bond length is represented? The units, there are two units which are usually represented. One is what is called angstrom, the other is what is called nanometer. Here again the chemistry people are fully know about all these things because the spectroscopy thing. Physics people may know a little bit because it is something to do nano. But putting everything together, you first of all have in your mind very clearly what is the relationship between angstrom, centimeter, meter, nanometer, etc. without getting confused. Now, again, as I said, which unit you are going to represent is context dependent. If you are talking of spectroscopy, earlier people are using the angstrom, but nowadays the nanometer is used. Even in the confirmation, some people use the nanometer and also angstrom interchangeably, whether you are British or American sometimes, it depends upon that. So it is necessary for you to know for two reasons. One is when you are reading a literature thing, they might have given something in the nanometer scale, you would have known something about the angstrom scale, and you want to compare it, you must know what it is. And this is the most confusing for everybody. So when you say that there are 2 points A and B, 2 atoms A and B, which are connected by a bond, then immediately I can say the bond length is so many angstrom. So when somebody asks you the question, what is the bond length of Cn, don't say Cn is 1.32, stop it. Please be sure that you mention that it is angstrom or 13.2, whatever you are saying is correctly there. The very important thing is precision. Don't allow the person who asks the question to see what unit it is. It should come from you. And the other thing is, I want you to be very clear in the nanometer angstrom business, because many a times you are likely to be misled. Okay, so we now have so many terminologies. So another term which I say is terminology. So this terminology, I don't want to say what terminology belongs to, then it will be an endless search. So the terminologies we are using are important. So when I say a parameter, it is a terminology I am using. When I say a bond length, it is a certain terminology, certain quantity I am representing, like that. We will go one step further and ask two questions. The first question that we are going to ask is that I am taking this particular system where there are two atoms which are connected by a bond. So I ask the question, are there different, you can use one of the two, any one of them, of bonds. If I say bond, is it okay, or are there different types of bonds? It is again elementary for people again from the chemistry stream and also from the biochemistry type of stream, that the answer is immediately yes, and ask them to list it, no problem, we will list one after the other. Starting from, I have seen if I take a vote, ask you to list, there will be 50-50 distribution to start either from covalent bond or the ionic bond. Nobody will start from hydrogen bond, I am sure, because that is well known. The fact that you have different types of bonds and each one is different from the other for some reason, that is the realm of chemistry, which again I won't be touching upon that for various reasons. But what is more important here is that we can ask a question, is this bond length anything to do with the kinds of bonds? Number two, there are two atoms at the end of the bond, the distance between which is the bond length. Now, is this bond length has anything to do with the nature of the atoms that go at the ends of the bond? If I have, let us say, carbon here and a carbon here, or if I have a carbon here and a chlorine here, is there going to make a difference in the bond length? The answer to the first one, as I told you, is very, almost you can find everywhere various types of things, and which constitutes a covalent bond, which constitutes a ionic bond, another thing. So, those of the people who have not even heard about this terminology, a few things which you can keep it in mind are covalent bond. This is not a complete list, but it is a sample. Let's say ionic bond. Then you can say metallic, or sometimes it is called coordination bond. And chemists will, if I say both of them are the same, but they are, for our purpose, we can take it roughly the same. And the fourth one is, we can call it even hydrogen bond. So like that, you can talk of the various kinds of bond. So you do some homework if you don't know about it. If you know about it, refresh your memory. So these are the various kinds of bonds. And then again, if you are talking of the ends of the bond as atoms, what are the atoms that get themselves involved in the various kinds of various kinds of bonds? Obviously, here again, fortunately for us, periodic table is there. And therefore, I would view the periodic tables as a blessing in such a way, because they have exactly defined some symbols for the various elements. And therefore, when you say C, you are not going to mistake it as calcium. you are going to take it as carbon because it is an understood symbol. Have you ever thought that C is carbon because somebody has said it and everybody has followed it? So that way, why I am bringing this point is confirmation, unlike chemistry or physics or many of those known subjects, is only, I would say, relatively recently it has come into the field. How much I would say, now this is 2000, so I will call it as less than 50 years. Whereas chemistry and other things have passed centuries. But it is necessary to have some sort of an understanding in the terminologies and other things of the confirmation in order the communication can be smoother. If people have used different things for representing different elements, how will the chemistry world be today? Forget it. So like that, when you are saying this, so the dependence of the bond length on the kind of atoms at the end is also a factor to be kept in mind when you are thinking of a bond length, parameter bond length. But as many of you know, that there is no such thing, I can say that if there is a C, so first types of bond, then one more thing I should add here and I have forgot about it, the types, and also yes, another thing which I will say, strength of the bond. And again, those of you who are familiar with the thing, the strength of the bond indirectly is measured by, at least in the case of covalent bond, a single bond, double bond and triple bond. So for us, the translation of a triple covalent bond between carbon and carbon or a single bond, ionic bond between two atoms, for us the parameter is still the bond length. So where does this difference is going to, let us say, exhibit itself in our work, or our understanding? That comes when you are not talking of a particular value, but you are going to go to the next steps of saying this bond length has a range of values. See, a range always means from some minimum to maximum. So, for you to know that definition of a bond length, if you want to define it precisely, then you say it is the distance of separation between 2 point atoms which are connected by a bond. So if you ask the question, what is the range of the, say, range of the single covalent bond between C and N, you are asking a very, very specific question. So answer to all these things, as I said, are details which you can get. So when you are talking of a bond length between atom C and O, which has a double bond, which is represented like this, then you say the bond length is 1.24 angstrom. And if you are not, if you don't know that whether it is a single bond or a double bond, if you know the range, then you can come back and then say it is 1.24, it cannot be a single bond, it has to be a double bond. Why? Because if it is a single bond, its range exists between here to here. If it is a double bond, it exists between here to here and things like that. So this quantitative knowledge of the values for a range is essential in order to know about the nature of the bond and vice versa. One more thing, useful thing here is, there are many occasions in which you have atoms and atoms are given to you in terms of some representation like coordinates. I am talking of a practical situation. And you don't have a chemist by the side of you to tell you whether this is a bond or not. But you know the ranges of the bond length then you have a way, you have a tool, you have a method of finding out which among those distances can be the point, and therefore you can know about the molecule. So there are reciprocal use for these various things. So now the way in which we have started the thing and the way in which we are proceeding is that this is the first class. So I have not gone much of the details of anything, but we will proceed in this way so that you will have to, let us say, either you will understand it well or you have to be patiently hearing me, one of the two things, whichever way it is.